Welcome you all to the video lecture on signals and system. Today we are going to find out inverse Z transform of given x of z. X of z is given by 1 plus z inverse divided by 1 minus 3.8 z inverse minus 0.8 z power minus 2. And they have given ROC condition. According to the ROC condition, we need to find out the value of x of n. So first let me find out the inverse Z transform. Given x of z is 1 plus z inverse divided by 1 minus 3.8 z inverse minus 0.8 z power minus 2. So first we need to convert inverse z terms into positive power z terms. So here when we compare numerator and denominator, the higher power term is z power minus 2. So multiply and divide by z square. So what happens? 1 into z square is z square into z inverse is z divided by again 1 into z square is z square minus 3.8 z minus 0.8 z power minus 2 and z power 2 get cancelled. And again as usual, when we are going to find out inverse z transform, first we need to take one z to the left hand side. That is, we should apply partial fraction only for this term. Why? Because while applying your inverse Z transform, all the terms it will be of Z by Z minus A or Z by Z plus A, like that. Okay. So for that we should have numerator Z in the final term. So as a first step, one Z we have to take from the numerator to the left hand side. Only for x of Z by Z we have to apply the partial fraction. So actually this term is nothing but when I take z outside, I can write it as what? Z plus 1. Okay. So this z I am going to take in the left hand side. So x of z by z I can write it as z plus 1 divided by z square minus 3.8 z minus 0.8. So once you have written properly the term x of z by z, now apply the partial fraction. Okay. So for the denominator we have to factorize. So when we factorize, we will be getting the term as z minus 4 into z plus 0.2. Okay. So when you multiply minus 4 into 0.2, we will get minus 0.8, and then minus 4 plus 0.2 is nothing but minus 3.8. So while using your calculator, okay, press mode and followed by that until that you will be getting equation. Okay, so press mode until you get equation, and once you get equation, press right arrow, you will be getting that a degree. Okay, so after going for the degree, since the degree is 2, okay, give 2 and then give a value, b value, c value. So here a value is 1, b value is minus 3.8, c value is minus 0.8. So use your calculator and find out your factors. So while using your calculator, you will be getting the value z equal to 4 and z equal to minus 0.2. So while you are rewriting here as an equation, you should write z minus 4 and z plus 0.2. Okay. Now apply the partial fraction. You will be having a by z minus 4 plus b by z plus 0.2. Okay. So now take your numerator in the left hand side. So z plus 1, that is equal to a into, so denominator you have z minus 4, other term is z plus 0.2 plus b into z minus 4. So substitute z equal to minus 0.2. So you will get a 0.8, that is equal to, so this term get cancelled. So minus 0.2 minus 4, you will be getting minus 4.2. So 0.8 divided by 4.2 is 0.19. So b value is minus 0.19. So use your calculator and find out your value. And then again substitute z is equal to 4. So 4 plus 1 is nothing but a 5. A into 4 plus 0.2 is 4.2. So 5 divided by 4.2 is nothing but 1.19. So once you have obtained your a value, b value, Now you can apply your a value, b value to this expression. So x of z by z is given by 1.19 divided by z minus 4 minus 0.19 divided by z plus 0.2. So which implies you have take your z to the right hand side. X of z is equal to 1.19 z divided by z minus 4 minus 0.19 z by z plus 0.2. Okay. Now apply inverse z transform. So x of z, for x of z you will get x of n, 1.19 remains as it is. Okay. What is Laplace inverse of z by z minus a? It is nothing but what is z inverse of? Z inverse of z by z minus a, it is a power n u of n. So when we apply inverse z transform 1.19, z inverse of z by z minus 4 is 4 power n u of n minus 0.19, for this term minus 0.2 the whole power n u of n. Okay. So this is the final x of n. So now we have x of n as this expression. Okay. But apart from finding out your inverse z transform, they have given ROC conditions also. For that particular ROC conditions, we need to find out what is ROC. What is x of n? So given ROC condition is modulus of z lesser than 0.2. This is one ROC. Second ROC, modulus of z greater than 4. Third ROC, 0.224. Okay. So first of all, how will you plot your ROC diagram? Your x-axis is real part of z, y-axis is imaginary part of z. Okay. So using your x of z term, okay, what are all the poles available? Here z is equal to 4 and here z equal to minus 0.2. So two poles are there. One is z equal to 4, one is z equal to minus 0.2. So minus 0.2 will come in the left hand side and z is equal to 4 will come in the right hand side. So wherever you have pole, just draw a circle. Okay. Anyway, when comparing 0.2, 4 is a higher value. So outer circle will be the circle across the pole 4. Okay. So we have two poles. Wherever we have poles, just draw a circle. And how many zeros? Z equal to 0 is available. So which is zeros are given by circles and it is existing at 0 value. Okay. Now they have given ROC condition modulus of z lesser than 0.2. So lesser than 0.2 means your ROC comes like this. Okay. So similarly, for this also the same diagram, but your ROC region varies. So one pole exists at minus 0.2, another pole exists at 4. Wherever you have pole, draw one circle. Okay. And this is real part of z. This is imaginary part of z. Similarly, for second thing, third ROC also, we will get minus 0.2 and 4. across the pole draw one circle. So x-axis is real part of z, y-axis is imaginary part of z. So for all the three cases, draw your diagram same, but modulus of z lesser than 0.2 means inside 0.2 you should have ROC, greater than 4 means outside 4. Okay, this value is 4. So outside 4 you have ROC. Between 0.2 to 4 means between 0.2 we have to draw your 0.2 and 4 we have to draw your ROC. Okay, and again whenever your ROC is lying inside a particular pole, that particular pole is non-causal. And again when you compare this pole, for this pole also your ROC is lying inside. So this pole is also non-causal. And coming to this diagram, here the ROC lies outside, so this pole is causal, this pole is also causal. When comparing this diagram, ROC lies outside of this pole, so this pole is causal. ROC lies inside of this pole, so this pole is non-causal. Whenever ROC lies inside, then that particular pole is non-causal. Whenever ROC lies outside of that particular pole, then that particular pole is said to be causal. Okay. So causal means write your expression as it is. Non-causal means change the sign. Non-causal means change the sign, as well as u of n you have to replace it as u of minus n minus 1. So this you have to remember. So u of n will be replaced by u of minus n minus 1, as well as you have to change the sign. Okay. Now come to the expression what we have obtained here. Okay, expression x of n is 1.19 4 power n u of n minus 0.19 minus 0.2 the whole power n u of n. Okay, so you roughly, let me roughly write here. Okay, so x of n is given by 1.19 4 power n u of n minus 0.19 minus 0.2 the whole power n u of n. This is the expression what we have obtained previously. Okay, so now what we have determined here, this pole is also non-causal, this pole is also non-causal. So minus 0.2. Okay, so I'll write in the green. So this pole is also non-causal. Okay, this 4. Okay, 4 is also non-causal. So non-causal means what you have to write, change the sign, as well as u of n, replace it by u of minus n minus 1. So for this case, after drawing the diagram, you have to write your expression. So x of n is given by, change the sign, minus 1.19 4 power n u of minus n minus 1, again change the sign, plus 0.19 minus 0.2 the whole power n u of minus n minus 1. Okay. So this is the expression for this diagram. For second condition, ROC modulus of z greater than 4. Both the poles are causal, so no need to change anything here. Okay. So write the expression as it is. So 1.19 4 power n u of n minus 0.19 minus 0.2 the whole power n u of n. Okay, write the expression as it is. Now, for the third ROC, this 0.2 is causal, but 4 is non-causal. Okay, so 0.2 is causal. Okay, 4 is non-causal. So how you have to write the expression? So we need to write the expression as x of n is equal to, since this term is non-causal, minus 1.19 4 power n u of minus n minus 1. This term is causal, so write it as plus 0.19. So causal means no need to change your sign. So write it as minus 0.19 minus 0.19 minus 0.2 the whole power n u of n. So for the third diagram, 4 is non-causal. So change your sign, minus 1.19 4 power n u of minus n minus 1. Here causal, causal means write the expression as it is. So I will be getting like this. Okay. Thank you. Thanks for watching.